missed it.
Ah,
You're
okay.
right.
So
Uh,
let's go through this.
okay, so
Ah,
okay.
now YouTube should be picking this up. It says I'm live, so I'll believe that. Anyway, so I don't know.
Then
Uh,
let's then just just do what you're doing now.
right. So I'm
If
in
you
this dogs generator script. I have no idea if you remember that. But that's a standalone script, hopefully close to the place it'll be in the pull request I'll eventually make, and the tool spec generator, or at least it should be in the tools directory. And the way it's structured now is this reads the docs pages, so it reads this top level components.rst, and it will look for these grammar snippets. That's a new Sphinx directive, and it'll basically replace its entire contents with whatever it generates.
right. So this would be sort of analogous to Sphinx build.
It should be analogous to, well, generating the grammar, generating the parser in the first place. Right, so
Oh,
the
okay.
parser
Okay, got it.
generator
So,
reads the description and generates a C file.
okay.
Uh, the difference here is that I'm touching this RST file that people wrote, and I'm putting some auto-generated stuff in it, which is usually a bad idea. Not the best thing to do,
Mm,
to mix auto-generated and handwritten content.
yeah.
But the reason I'm doing it is because I want these to show up in reviews. When somebody changes the grammar, they should also look at the effect on the docs,
On the
because
docs. Oh,
the
yeah.
text next to that needs to reference the grammars sometimes and things like that.
Okay,
So that's the
cool.
reason I'm tolerating some not nice behavior, uh,
So,
because mixing this in one file is doesn't play well with tools and stuff like that.
mm,
Anyway, so that's it. That's there's a script that takes the grammar file name and the docs directory, goes through all the RST files in the docs directory, collects, well, basically only looks at these headers. So it collects all these, I call them top level rules, the ones that we want to document. And then for each of the snippets, it generates the grammar for that rule and everything that it depends on that isn't the top level rule itself. So that's maybe a bit hard to explain. But for example, for this file, I also want to generate the statements rule,
oh,
but
okay.
not the statement rule because that's documented somewhere else.
Interesting. Okay.
So
I think I'm following.
Sphinx
Yep.
will now give me a statements link to the same place. That's not ideal. Maybe could not make that a link. But statement is, this is a piece of the old docs.
Hmm.
The way that's set it up right now is I have a hard-coded list of stuff that's documented somewhere else.
Right.
And once I go through all the RSD files, that should disappear. Right, so yeah, goes through all the files, updates all the files, and then there's the fun stuff with my own classes for all the grammar items. I think you were here when I first wrote that.
Yes. 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 That's right.
And there's giant ugly function that converts from the parser output to, or the parser representation to mine, and remove stuff like negative look ahead, and then well, some functions to tie it all together. There's one interesting thing now where... Right, so removing invalid rules is a bit different now. So there's the simplify item in choice. So choice is the stuff like one or the other.
Oh, okay. Right.
And that now has a simplify item method, which well, gets called for each item, and it has this very complex match case. It's a sequence with one non-terminal which has a given name. If that name starts with invalid, then the whole item is removed or replaced with nothing.
Okay.
And the reason I'm able to do this is because everything I have here is a data class, and data class automatically sets up the machinery so that I can do sequence, and then in parentheses this one thing that's in the item. That's this items, this list of nodes. So that's matched against this in the case. For non-terminal,
cool.
I have well, non-terminal is a leaf which has one data class thing in it, and that's value. So again, this will match the name of the non-terminal. And that is really powerful.
Yeah.
I hope I don't abuse it too much. So what I was doing before is try to put the parentheses in the right place. And I have left that for the next stream. Wanted to think a bit more about it, and I haven't actually researched how to do it, but I remembered there is an AST module in Python that has an unparse, unparse function or unparser, and that basically takes an AST tree and prints it back as an expression or as a string expression. And that I see now this has require parents as a decorator. Let me look here for some notes about what it's doing. So it does require parents with operator precedence. A node, right? So the input to this decorator require parents is the precedence of the operator I'm printing out, and the node itself. How does this work? It sets precedence. There's require parents and set precedence. Oh, it sets precedence of the node inside it. That's interesting. And what does set precedence and does self preferences node? Oh, I see. So self underscore preferences is a dict of nodes to precedences, because the unparse cannot really attach attributes to the nodes it's handling, so it needs to have an internal dict.
Okay.
I have my own classes, so I can just put this in attributes. Let's get precedence, and then there was the require parents, which is delimit if. So it's delimit with parentheses if the precedence of the node is bigger than the given precedence. Yeah, that looks reasonable. And what are the preferences or the precedences here? Right, so this is, I guess, copied from the documentation somewhere. Expressions operate through precedence, right? So these are the operator precedences in Python, and I guess our list will be very similar to that. Named expression, there's tuple, yield, test. Oh, I guess it goes backwards. So named expression is the assignment expression. I don't see yield here, but there's
I don't see lambda.
Test or
okay.
and not, compare, express, whatever, booleans, shifts, term factor, and all the way up to atom. And atom is everything that's I guess doesn't ever need parentheses because it usually already has them. Right, so that looks reasonable. I will want something like this for the grammar. So let's import enum, and I will need precedence derived from enum.enum, and where would I look for the grammar? Here, metagrammar. So this is everything that can go in the grammar. Does this help with precedence? I don't know, maybe I should look at what I have here. So how is this ordered in the AST? So the first thing is the thing that binds least tightly. Is that right? So if you have some plus or comparisons in one of these, it doesn't need parentheses. And the thing that binds least tightly in our case would be choice here. So choice as enum.auto. And maybe I want to make this int enum so it's just can be compared as integers. Right. What's the next thing? If I have a sequence, I guess that's the next thing. Atom here is the last, and that would be everything that's either in parentheses or it's this leaf that doesn't have any internal structure. So well, we can call that leaf. And there's the sequence. And what is these optional and stuff? I can do that similar to Right, so if one or more has a sequence inside, then don't need parentheses. If the one or more is in a sequence, then the one or more needs parentheses. I don't know, this is very hard for me to think about. Operating precedence rules. Right, so if one or more has a sequence inside it, that sequence needs parentheses around it, so that the plus here applies to the whole sequence.
Oh, I see what's going on. Okay.
Right. So if one or more is in sequence, one or more needs parentheses. Let's compare that to this. Right. So if named expression is in, let's say arithmetic plus, then the name expression needs parentheses. And the name expression is on top here. Alright, so let's go back. If this is in that, it needs parentheses, so one or more should be on top. Okay. And I guess that's, let's call it repeat. Auto. Okay, and if choice is in a repeat, I guess that doesn't need parentheses. I guess the repeat should be at the very top. Right, basically I hope. So let's try like that. And now how will the algorithm work? So when do I need these parentheses? I should I guess I need to thinking on the stream, that's never good.
Well, would it be useful to write like a little description as you go along, so that you don't have to keep everything in your head?
Right. That makes sense.
Even if it's just temporarily, even if it's just temporarily, like a little note to self.
Yeah, so what do I need to do? I need to assign a precedence to every node. Right?
Okay. Right. So for each node, we could make a little note of like...
I just put in a precedence attribute. Okay. So normally, let's do it for the easiest one. So leaves.
Okay.
Precedence is precedence.Adam. Okay. That works as a note. Gather. What would be the precedence of this gather? Do I need a special... I guess the gather with its plus thing would be very similar to things like 1 or more and 0 or more. So let's say its precedence is this repeat. That's basically repetition. Okay, 0 or more and 1 or more. I guess those are those repeats. Optional is always in parentheses. So I guess its precedence will be Adam. This should act as the lowest thing in the precedence chain. Okay, did all of the decorators. Sequence, we have a precedence for that. Right, sequence. And choice like that. Okay. Right, and now when I format, I either enclose the item in parentheses or not based on its precedence. So if the precedence is lower, so this is probably 0, like sequential numbers. So if the item's precedence is lower, then I will need to put it in parentheses, right? For example, if I have a sequence of repeats or a sequence of choices,
okay. Yeah.
I'll need to put it in parentheses. Is that right?
Yeah, because it happens later, right? Okay.
I mean, it's either one or the other. So we have format enclosed. Let's not do that. Let's get rid of format enclosed because we should be handling this here. And let me put this in a proper loop. Representations is a list, and for each of the items, let's say if item's precedence is lower than choice, then I put parentheses around it. Something like that. Does that make sense?
Yes.
Okay, let's do the same thing for sequence. So that should be like this. Now for decorator, optional never needs to add parentheses. One or more sometimes needs to add parentheses. So let's get the format again, and if the precedence of that is lower than repeat, then let's add parentheses again. and at the very end put in plus, and that should take, what I'm doing now should take care of this to do, right? The same thing is for 0 or more. The only thing that's different would be the star. And for gather, we need to do this twice. So sep representation is this for separator. And this is a lot of copying and pasting, but it's just to show the structure, so I'll be able to refactor later. Okay. And for atoms, I don't need to do anything because
Right, they stand alone.
there's no internal items, right?
Right. They have no children.
Right. So put in some selves. Where's that? Oh. Self item precedence. Self. Okay, how did that work? Quite interested. Huh.
Wow.
That doesn't look too bad. I probably want to compare the string representation I'm getting from pgen to just see what I'm looking at. Okay, this is probably very wrong. So, this statement plus gets put in parentheses, which I don't think is necessary. And it's put in parentheses because it's part of a choice. Yeah, the choice only has one element in it. So, right, when a sequence only has one element in it, it probably needs to act as that element, so it needs to get its priority. Right, what's next? Everything here looks pretty good. I'm not getting parentheses around these sequences, which is good. But I am getting parentheses around this gather, which I don't really want. Right, so how does this work? Something's wrong here. So this is comma expression. Let's look at the full grammar specification. Expression. So this is expression, and then comma expression is in parentheses, and then we have a plus. Okay. So this is exactly the other way
Yeah,
around.
that's it. Oh.
Are the priorities bad? Should like repeat be below? I need to think about this.
Is it a repeat? That thing?
It's a sequence inside a repeat.
Oh, I see. Okay, okay. Oh, okay. Yeah.
Yeah, that looks better. Yeah, so this is this is looking pretty good for the limited examples I have now. I will probably run into something weird later on, but for now this is fine. Oh, actually not. It actually doesn't need very many parentheses at all, so that's okay. Let me just add a little to do here. Now a note, check parentheses are correct in, let's say, complex cases. Okay. And it looks like I don't really need to handle the case where I'm getting parentheses around this one element sequence in a choice. It's good. I hope it doesn't bite me in the future. But looking here, at least this case is already better than the stringification I get from the parser's debug output. So that's good. Probably have a comment or a docstring, but let's leave that for now. How does this look? So, oh, there's a more complex case I have in simple statements. Let's go there. Simple statements. I went for the delete statement. Hey, what's happening here? So there's some simplification going on. So the del statement has this look ahead removed and the invalid rule removed. So that gets whittled down to that. The del targets look good. The question mark is replaced by the brackets. This look ahead is removed, so I have t primary name or t primary slices or del t atom, and del t atom is just a choice between several sequences. So this isn't actually a very complex case, but it works. Let me comment this out. later. Okay. So what changed? We have precedences everywhere. We use those precedences, and that's basically it. Looks like quite a simple
On
change.
line 31.
Yes.
On line 315. 315. There's a G in stringification.
Oh, thanks. I wonder how this algorithm will work with more complex cases, but it's working for now. What I want to do is make this a bit drier. So I'm repeating these 3 lines over and over again. Right. And I guess that could make a method on Node. So I format self, and if my I call this result
Nice.
name, and if my precedence is smaller than the parent precedence, I enclose the format in parentheses and I return the result. Right? So now let's this can go back to generate expression. Oh, and I need this. Never sure how to format code like this. PEP8 is not very helpful in this respect. Anyway, this is the same thing for sequence except for the separator. And then here, this is for repeat. Parentheses, so self-separator, and this is not item but self-item. So instead of format, I will do format for precedence. Nothing changed, and the result except my debug output is gone. I didn't commit that, probably should. Oh, right. Need to add one more file. Whoa. This one. Right, that works quite nicely. So what's the next step here? I guess one thing that could be done is more simplification. Let's see what happens when I have simple statements like this, and I have two choices, and each one of them ends with this new line here.
No.
So I might want to scratchpad here. Instead of that, I might want to take the new line out and do something like this. Oops, one space is here or not? Is that better?
Mm.
And for the railroad diagrams, it'll definitely be better.
Yeah.
But
Yeah,
is it better for the text representation?
You know, it feels like parentheses. You know, when the sequence is that long, then you get into like a balancing. You know, visually, it seems like it's easier to read without the parentheses because it's just dot dot or this or that.
Right.
The parentheses kind of force this little cognitive nesting operation where.
But one thing it does is it allows us to simplify further. Because if you now look at this,
yeah.
there's
It's
a simple statement or simple statement repeated with semicolons in between and an optional semicolon later.
Oh, that's
right?
nice. Yeah.
This is a special case of that. So we can just do bam.
Oh wow. Oh yeah, that is nice.
And I don't know if we could do that easily without bringing this new line out. And I wonder how that'll work with something more complicated. I guess my other case here isn't really that complicated. And also, I wonder how this will look once we do add the railroad diagrams. If it'll be better to match the diagrams, even though the text itself is a bit harder to understand, or to make the text as easy to understand as possible, but make it not match the diagrams as well. Well, I guess the best way to find out is to implement it and see. So how would I go about... Oh, this is an interesting case as well. So we have statement new line, which has compound statements, new line, or simple statements, or just a new line, or an end marker. eventually I would probably want to inline the simple statements in here, and then maybe get rid of the inlines, the new lines. Something like that. At least for the railroad diagrams, this would be better.
Yeah, yeah. I
Not
see.
sure about the text. Also, when to inline stuff, that's another thing. Right, aggressively inline everything. So one simple rule that could work is inline something if it only appears once in this block. Right, so here I would inline statements because it's right there.
Oh, okay.
Here I would inline statement new line because it only appears here. But for example, if there was simple statement documented here as well, I would not inline it, so it goes in both. So I would not inline it in both places here.
Oh, that's a nice. I think that'll create like a nice kind of cadence.
Well, but then I will want to simplify it down to where there's only one simple statement, and then that gets inlined somehow. Or maybe I want to look at more grammar and see how stuff should be simplified more generally.
It seems like this is the sort of thing an AI would be good at.
Really?
Well, I don't know, just looking at all of the patterns.
I am not very comfortable asking AI what is readable or not.
Oh, okay. Yeah, this is a speculation on my part. I don't have enough experience with it, but
yeah, me neither. I don't really have an account anywhere, so I haven't tried that yet.
no, I don't. Yeah.
Well, let's do the thing that's simple to.
Yeah, I think so.
Implement. So if I have three choices that each begin with
Expression?
with the same thing,
Okay.
then I take the same thing out and so let's. How will that work? How will that work? So if all branches of the choice begin with the same thing, or do I look at two consecutive branches every time? Well, I guess let's do the easy thing first and look at all the branches. So this would be for choice, and for simplify I need to specialize this. So if all of the items begin with the same thing, so if all how do I get the first child? So this items is a list of nodes, and the nodes should all be sequences. Okay, so let's have an invariant. We'll say that we want all items of a choice to be sequences. Okay, that should currently hold. At least for our cases. And now we can look at the items and get the first one. So if all of an item first thing of an item this is getting quite hard to follow, isn't it?
A little bit.
A little bit. So I should probably name things more, right?
How about?
Okay, so choices or branches. Let's see. How do you call the things in a choice? Like what is this?
The option?
This
The options, the alternative
options.
choices.
Alternatives, right?
Alternatives. There you go.
Alternatives is a better name for self-dot items when we're in a choice. Okay. The first alt will be alternative number 0. And if the first item of each alt is the same as the first item of the first alt, for each alt in all alternatives but the first. Does that make sense?
Yes, it does. And it's much better than the old way.
Right, and I also want to only do this if I have more than one alternative. Well, if I only have one alternative, oh, and I shouldn't be using items, self items here, because I haven't just got this list of items. Let's do that for Uh,
So let's see. So like if alternatives one is true, then don't do this.
well, if I only
Yeah, or if length's alternatives.
have one or zero alternatives,
Yeah.
then I
Less
don't
than.
really have a
Okay.
choice anymore.
Right.
Right? So if I only have one alternative, then I should return it.
Yeah. Then exactly.
Right? And if I have zero alternatives, which is spelled if not alternatives, then I should return an empty container, which, well, I'm using empty sequence for empty nodes. Right? Okay, so now we can safely get the first alt. We cannot safely, we can always safely get the first item because we have removed all the empty items here. Right, so we know that there's always a first item in all our alternatives. And let's use alternatives for the first part of this. Algorithm as well. Right. Okay, so
Yeah,
now,
instead of like. Yeah. Okay.
if all the first elements are the same, then we return a sequence with the first item and a choice, and this will probably need some wrapping, and a choice of all the alts without the first item. Like this.
Mm-hmm.
Let's see if that works. Yeah, I guess it did something, but I'm not getting enough parentheses.
Mm-hmm.
There should be parentheses around this. And I will be getting into some interesting edge cases. So how does this work? Should I have sequence before choice or something like that? No.
Oh,
No.
I suppose so because choices and repeats are both sequences.
Oh wait, that won't really
Is that
help
right?
me.
It won't. Okay.
Let's just parenthesize everything. See how it works for now.
Yeah.
Okay. Whoa!
Oh, it's like Lisp.
It is like Lisp. So yeah, we have expression and I see a bug we have in the simplification code. So there is one problem here, which is unrelated for now, but we'll be getting a lot of edge cases here. So when I have an empty container as part of a choice, I can't just remove it because that makes the whole choice optional. Does that make sense?
Oh, right, the whole choice. Okay, yeah.
So let's do this for now. And then whenever I return, I need to wrap this in optional.
Oh.
An optional nothing is still nothing, so not there. And how do I wrap? If this whole thing is optional, then I return optional node, else I return just the node itself. So, did that do anything for us? No, not really. Huh. Okay, this is not what I was going for. I might want to work on my debug output, because apparently parenthesizing everything here isn't really working out for me. This is not what I want, and I need to get some insight into the structure that's resulting in this thing, right? So let's do a quick dump method everywhere. This stream is really messy, isn't it?
Oh, life is messy.
So, how do I dump a tree? I guess with an indent, right? The base case would be some indent plus just self format. want to start this with a colon. And I want to yield lines. Just so. So this is an artifact of me.
PyCharm might pretty print that for you.
Go ahead.
I was just saying, if we put a breakpoint, PyCharm might pretty print it for you in the debugger.
Oh yeah, that's true. Or I could also just use pprint.
Okay.
Yeah, but I'm running into the problem with mixing hand generated and auto generated content here.
That's right. We were joking about how that was going to bite us eventually.
Yeah, it's biting us, all right. Nope, still nothing. Did I save this? It's working for delete. It's not. So this should only be yielding one thing. Come on. This worked so nicely before. Oh, I didn't restore everything. That's the problem. Well, it's biting us, all right. Okay, so this is getting us just the representation, and I will need to override that to get prettier dumps in containers. So these parentheses. So I might be easier to use a debugger, but I also usually find out that I want to do something different, so it usually pays off to do this kind of debug output. I think think the pgen itself also has some kind of tree dumper inside it.
Oh.
My name. Come on, my fingers aren't working. So here we have a name. Let's put a colon at the end for good measure, and then for each item in this will yield from item dump tree with one more indent. Ah, there we go. Okay, let's put one more space here just to make it nice. Okay, so this weird one is a sequence of expression, a choice with a sequence of expressions and an optional comma and a comma, and there's an empty sequence at the end. So yeah, this is actually correct, but the parentheses adding code is messing everything up. Yeah, so what do we want? If there is a choice inside a sequence, that choice needs to be parenthesized, which it's currently not. So if there's a choice...
or alternatives.
Yeah, if there's alternatives inside the sequence, this needs to be... This needs to have parentheses around it. How are we doing that? So it's inside a sequence, so it's sequence format. So it's formatting. Oh, this should be a parent. Is that it? Nope. So if I'm formatting choice, so self-preference is choice, parent precedence is sequence, I want to add parentheses. So here I want choice above there. Does that make it better? Yes, that is exactly what I wanted. Okay, so what we have now here is there's expression, and then there's these choices. Does that make sense?
Yeah, so far I follow.
Let's also add this thing I commented out just to see what we're starting with. Come on, Sphinx. There we go. Right, so we had this, and the expression got taken out, and we're left with this. Looks pretty good. The problem here is that we don't really want an empty alternative in these choices. Instead, the whole thing should be optional, and we should get rid of this empty thing. Right? And we're already doing that, but we're not doing it recursively enough, I think. So this is creating a new choice, which needs to be simplified. And I wonder how long it will take until you run this simplification in some kind of loop that recursively simplifies everything and tries that until it stops getting a new result. Alright, so what do we have now? We have expression and then optional choices consisting of either this comma or this whole thing. Looks pretty good, doesn't it?
Yeah, it really does.
The tree doesn't look very good here because the optional needs to be spelled out. So let's specialize dump tree for decorator as well. And
Wow,
we have a problem.
that's okay.
So there's an optional choice of sequence or sequence. So far so good. But then there's one or more choice with a sequence. And then this is a choice with one arm. Right?
Yeah.
Edge doesn't really get simplified well. So let me do one more thing with this dump tree. So that works for decorators. This gather will need a dump tree as well. We have that. Where's the gather? Here. So let's do a nice pretty printer as well. So this will have another header. Choice another thing here. Okay, so we'll get one Sphinx. There we go. So this gathering simple statements with this separator, so that looks good. The rest is leaves, which are fine, just being printed out. Yeah. So how do we fix this problem? I guess the sequence of one element might need to be simplified. The problem is if I convert a sequence of one element into just that element itself, we lose the invariant that the choice only contains sequences. So that's not good. But the problem here is this choice only has one arm, so that should really be that should really simplify to just this comma.
Didn't we have a thing for leaf? Wasn't there a method for leaf, or is that like no?
For simplifying leaves, or a method?
Oh, I see. No. Sorry, I realize leaf is the thing we're trying to simplify. Okay, got it.
Yeah, that's the thing we need to simplify too.
Yeah.
Are we? Oh, maybe we should.
Unwrap.
Unwrap. So we're creating this this choice and simplifying it right there. Where else are we creating choices? I think we're only creating there. Or there's also self-type. So here, if we are stuck with one alternative, then we should just return that alternative.
Oh, yeah. In other words, there's no need to wrap if there's only one
Right.
alternative.
Yeah, no need to use the choice at all. Right. Problem is that doesn't get called. Why not? Does optional simplify its item? Optional is a decorator. Oh, and a decorator doesn't simplify its item. So let's simplify that. Well, how do I call this? Self-type. Self-type is the type of self. Okay, that looks a bit better.
Yeah. Yeah.
So now we have this optional sequence of one element, which might be simplified more, and it's probably best to do that in the decorator, so we don't simplify too much. And let's use a match again. So if we have a sequence of one element, we just use that element. Okay, and now instead of optional sequence, we should have just an optional comma. And this should be as simple as it gets now, is that right? I don't think we can do much more. Well, we could do something more. And no, I don't think we could do anything more here. Could we? Probably not. Let's look at this one. So there's simple statement, new line, gather, optional, new line. This looks good. Compound statement, new line, simple statements, or a new line, or a new marker. This looks okay. This looks okay as well. Okay, so I think this has been successfully simplified now. Question is, which is better? This one or this one?
Well, the short one does have a little bit of maybe higher cognitive load.
Yeah.
But maybe it's better for the railroad diagrams.
It's definitely better for the diagrams.
Yeah. And the diagrams
better as text.
But aren't the diagrams always available? Or, oh, I guess not for like a man page or something like that.
Uh,
In other words, should we be optimizing for diagrams?
so I think if somebody's looking at this documentation as a man page, uh, while they have a browser
Yeah,
on
yeah.
on their screen
No,
anyway,
no, no, no.
they're just punishing
Yeah,
themselves. On the other hand,
yeah, yeah.
if it's, for example, a blind user,
Oh,
then
yes,
we cannot rely on diagrams.
that's true.
But I have no idea how this will sound when read out loud. Uh,
Oh, maybe we should give that a pro. Is there do you have like a text to speech thing on your machine?
Not maybe. I
No.
have no idea.
Oh, okay. Yeah, right, right. Exactly. Yeah.
And even if I did, it would probably not make any sense to me. So that's that should probably go through some usability testing.
Mm.
It's an interesting thing to think about.
Yeah.
What to do with this? Do we have any hard of seeing people on the stream? Probably not. Since
Mm,
this, this
probably
is
not, but there.
this is on YouTube, so it's a video, right? I mean, the simplification can be enabled or disabled later, so
Oh, there.
it
Okay.
will
That's
need it
good.
eventually for the diagrams anyway.
Oh, well, in that case, yeah, in that case, let's. We don't have to worry about it. I mean, it can be either toggled on or toggled off.
Yeah.
Okay.
Okay, let's.
Yeah, definitely. And yeah, unsimplified would certainly be, I think, easier to hear if someone's. But if it can be toggled on or off, let's just keep going. It's nice simplified. In other words, it's
So,
working.
if we simplify even more, we can probably get this expression to only appear once in there.
Wow.
Because
Yeah.
what this is doing is
Yes.
I don't know why it's not using gather even. Right? So this is
Mm-hmm.
expression, then comma expression repeated, and an optional comma. This is gather, isn't it?
Expression. Yeah. Expression star. Oh, that's a plus sign. Okay.
Yeah, that's a plus sign.
Okay.
But there are these cases, right? So this is optimized for the parser, not for humans to understand it. So this whole thing is expressions separated by commas with an optional
Right.
comma at the end.
Oh, right.
Right? This
Right.
thing is expression with an optional comma at the end. And this is the most general case.
Should there be a space after the plus, or between the closing parentheses and the plus? A space between them?
Here? No, that's...
Yeah.
plus
Okay.
binds quite tightly to this these
Okay.
parentheses.
Very good.
I don't know if we want to put space inside these parentheses, but in Python you wouldn't do that, so let's not do that.
Okay, let's do that. Okay, that's fine.
Huh. I mean, we have a similar thing here, right? So if we put this new line out, we'll have either simple statement or gathering simple statements with an optional semicolon at the end. So this is just a special case of that. Right? We can get rid of this entire alternative. Well, let's say this works now. So I'll put it in Git with all the debug output. That's a terrible word to spell. Start simplifying jokes. Okay. We should do the same thing with the last element, right? Because here we have new line appearing at the end of each alternative, so that should receive the same treatment. So this is a lot of code to just copy, but so if the last items match, then we do the same thing, but our sequence will have the last elements at the end and everything but the last element in the trace. And I'm missing a comma here. Okay, so that got simplified quite well, as you can see here. So new line got
Sweet.
Got to the end, and now just reorganized everything, and now we can have a special case for this, right? If we have a choice with something and a gather of something with any separator and anything optional at the end, then we can get rid of that something because it's a special case of the gather. Does that make sense?
Yeah. Yeah, I think so.
I wonder if that's too much of a special case. So we have a sequence of one thing and a sequence of a gather of that thing and a separator, and then an optional anything, right? And that means we can I use x and x2 because I can't use just x, that Python will complain. Right, multiple assignments to the name x in pattern. So the way it needs to be handled is to do x1, and they say, let's say if x equals x1, I have no idea how that should be indented. And then this sequence here should be the result. Say that maybe.
Sure. Yeah.
Oh, and this if needs to be here.
Yeah, I've never really used match case.
I don't think that actually matched though. So let's see. So the alternatives should be a list of sequences. We have that here. So it's a sequence of. Let's look in here. So it's a sequence of simple statement here, and then a sequence that gathers a simple statement with any separator, and then there's something optional. I wonder why that doesn't match. Doesn't get here, right? No, not at all. Simplifying all the choices I make. Well, time to print our alternatives. So where do I get that? So simplifying is there a new line at the end? No. I guess it's a sequence that we get as a result somewhere here, and we're not simplifying that. Right, so whenever I make a sequence, I need to simplify it. Which means there's a lot there are lots of simplify calls. I'll need to refactor that somehow later. But what do we get now? The same thing. Yeah, it's the same thing still. Now I'm simplifying every sequence I make.
I'll be right back.
Oh, well, maybe it's time to end this and get a few nights sleep. And try looking for a fixed point a bit later.
So how do you write like a failing test or something to remind you where to pick up?
No, I just
Or
look
to
at
do
the
item
current
or...
output and see what needs to
Oh, I see. Okay.
what it needs to be done next.
Okay.
Yeah,
Nice.
I'm not writing any tests here because the tests, well, there is a known output, so the tests are, you know, run the tool and
Oh,
look
I
at the diff.
right.
And I don't think we'll really need any more tests. I don't know if Pigeon has any tests. No. Not here, at least. Of course, testing is good practice, but if you have known output, it's
it's kind of
not that important. So, simplifying sequence with simple statement and a sequence with a gather and an optional. And I have no idea why this doesn't match. Why does this not match? Does the structure match, but this doesn't? Yeah. That's interesting. Right, so now that's simplified, but I do need to check that this x and this x1 is the same. So what do we have here? Oh, how did I define gather? Gather has the separator first and then the item, of course. That's how it's written in the grammar. Ah, no, now it works. Okay, get rid of that debug output. Right, so now simple statements.
Oh, nice. Nice. Okay.
Simplified this whole thing to that. So it's just a sequence with a sequence inside, which is not optimal, but that could be the next steps. Simplifying nested sequences. Yeah. So that got simplified. The bad thing about that is it's just a very special case. but hopefully when I write more special cases like that, it'll be easier to see the patterns. Okay. So now question is this better than that? And I guess that depends on the occasion. If you want to see if simple statement new line is valid simple statements, then seeing this would be better. But if you want to know how it all works, then this is better. Yeah, so I guess in most cases the simple thing should be better.
Yeah, what does the Zen say? Simple is better than complex?
Yeah, it could as well say better is better than worse.
Yeah.
Alright, so the next step is nested sequences. We don't want nested sequences, do we? So this should be a sequence of a gather, optional, semicolon, and new line. So where's the code for that? This is getting quite complicated. So sequence doesn't yet have its own simplification code. So there we go. So we match this item here, and in case we have a sequence, then we extend our list of items, which with simplified version of each sub-item. Right, so that got rid of these nested sequences. It will probably not get rid of like 3 levels of nested sequences, right? Because I should ideally see if this sub-item is also a sequence, and in that case explode that. But let's cross that bridge when we get to it. I'm probably looking for a refactoring that'll make that not important. So
yeah, it sounds good.
Okay. Right, so simple statements is now a sequence with one element. That's one special case where we can do better. So if we have just one item, we return it. Right, but we can't do that because we break the invariant where sequences always remain sequences. So that's the first thing to be fixed. Here. So far, everything in choice needed to be a sequence to simplify the following code. Right? To simplify this mess here. If we want to convert one element sequences to the element itself, that will no longer hold. What to do with that? Well, to enable this, we want the alternatives to be lists of stuff.
Right.
So let's just use lists of stuff. Okay. So if we have a sequence of items, am I using the name items anymore? Anywhere, yes, but later, so this is fine. So if we have items, then I will append.
You could say elements if you didn't want it to confuse it or something. Or I don't know.
So I will append these elements as a list to the alternatives. And otherwise it's just one thing, so I'll do a one element list like that. Right?
Yeah.
So I'm unpacking all the sequences, and now I need to change all the code that does this. So this is a one element list. This is a two element list, which needs to be converted to sequence. If I have just one thing, then I need to convert it back to sequence. And ideally simplify it. I need to simplify here as well because I'm creating a new sequence. No alternatives, empty sequence. First alt is the first alternative, and now I'm using a list, so I don't need to do items here. Right. And alternatives are now lists, so I need to do a sequence. Alternatives, and again I'm creating a new sequence, so I should immediately simplify it. Right. And now all the items should be lists. Something is very wrong. I just got rid of everything.
Oh shit.
Oh, I need to do a list comprehension, not a generator expression. Okay, so that was a refactoring. It didn't change anything. So what went wrong here? When I get rid of the list parentheses or the list brackets, I'm making a generator expression. Problem with generator expressions is that it can only be iterated through once. And
right.
as a quirk of Python, that's unfortunately very hard to undo. If you try to iterate over this again, you'll get nothing, because it's an iterator, it's already at the end. If you want the next item, there is none, so that's like an empty sequence. Right? So I need to make this a list, so it actually stores everything in memory and iterates the whole thing every time. Right? So that didn't change the output,
right.
That's a good thing. And now I can go to sequence and do the thing that I removed earlier. So if I only have one item, I return it. Okay. And that's right. So it changed this choice of a bunch of sequences into a choice of just simple stuff, and this sequence of one thing into a simple thing, this sequence of one thing into a simple thing. Yeah, that looks very good. Of course, when printed out, it doesn't really change anything, but it's a simplification in the internal structure. And what do we have here? There's a choice of this sequence and the comma. So this is as simplified as it can be, unfortunately. Okay, so that's good. What did I commit before? Simplifies the sequences. And this is single element sequences. And I'm afraid that's it for today. I'm out of time. Thanks for watching. Hope this was interesting.
No, thank you. This was great. Awesome.
It was.
I'm looking forward to the next one.
Nerve-wracking, typing and typing while somebody's watching, but I'm trying to get better at it.
Oh, so if you like, I mean, I'm happy to do pair programming. So if you want to take turns typing, we can do stuff like that.
Ooh. Would probably require some kind of specialized editor, right?
Oh, well, no, you have PyCharm, right?
No, this is Kate.
Oh, okay.
I guess I could.
Well, I have
PyCharm.
PyCharm has live editing. You can share it. Yeah.
That could
so this is
work. Kate. Probably not something I want to do in the end.
No problem.
If this is working, if you can follow this, then.
Oh yeah, no, that's not a problem at all. But I was just, I respect that there's a lot of multitasking taking place if you're trying to do it,
Yeah.
all of that. So.
And I guess that's what I'm trying to get better at. So. Practice makes perfect.
Yeah. Well, practice. Yeah, absolutely. Yeah. That was awesome.
Well, thanks for your time.
All right then.
And